Hi there and welcome to Science Sidekicks and another video where we are looking here at Tinkercad. So in our last Tinkercad video we made a basic circuit and program. For those of you who didn't see it, basically what Tinkercad is an online simulator for your Arduino and circuits. So if you don't have access to an Arduino for whatever reason, you can still follow along with our tutorials and YouTube series. You can still learn about electronics and programming. All you need is access to a computer and the internet. If you do have an Arduino kit, then you can use this to prototype. You can use it when you're traveling and you don't have your Arduinos with you. You can work on your programs, you can work on your circuits, and you can output this then later to your actual physical Arduino. So think of this as a digital twin model of your real world kit. So in the last video, we created a really simple program where when we push this button, the LED comes on and off. Okay, so the program is really simple. We set two pins, one to input and one to output. So obviously the input pin is number 2, which is connected to our switch because that's an input to our Arduino. We want to tell the Arduino something when this switch is closed. Pin mode number 3 is set to output because what we want to do here is output a voltage and turn on our LED. So we created an integer called switch state, which we set to 0. This is a digital input, output, so it's a 0 or a 1. So that means that when we push the switch, it's going to turn the pin high or low, and we want to change that digital value from either 0 or 1 for high or low. So we then have a loop. So we say if, and we read the switch state, digital read is equal to a digital read on 2. If switch state is high, then we want to turn pin number 3 high, which will turn on our LED. And if the switch state is low, we want to turn off pin number 3, which will turn off the LED. And you can see that's what's happening here. When we push the button, the LED comes on and off. Now, what we're going to do in today's video is we're going to add another switch into here. But this one's going to be physically connected. So one of the switches, the first one that we did, is connected to the LED only through the software. So the software is making the decision whether or not this light is on or off. There's no physical electrical connection between the switch and the LED. They're two separate circuits. If you look here, we've got power coming out of pin number 3 into the LED, and it's coming back to ground through this resistor. The switch, power comes out, goes to the switch. It gets pulled to ground if the switch is not open or closed. That's how we get the high or low. And then it comes back here. So they are two separate circuits. However, you can add a switch which can control the LED directly. So let's add another push button switch into here. Okay, and this one is going to be connected in series to the LED. So you might think, well, that's going to be pretty straightforward. We're going to connect the positive here to the positive input there. So we'll make that red, and we'll make the positive then go to the anode of the LED like so. And we've already got the resistor on the negative side there. So this should all work now, you would think. But let's see. Oh, we've got a problem. We've blown something up. Now, what do you think that might be? Okay, well, I'm going to tell you. Basically, we are feedbacking power through this here. Okay, and what we want to do is we want to restrict the power from going back that way. So what we're going to use is something called a diode. Now, what a diode does is it prevents current from flowing in the opposite direction. It will only allow, it's like a gate, it will only allow the current or the voltage or the power to go in one direction. So we're going to add a diode into this circuit. Now our breadboard isn't quite big enough, so we're going to need to make a little modification here. We'll drag that over there, and we'll now connect the output side of here to our LED. Okay, now on between here, we still need to connect pin number 3 because I still want my program to also work. I want to have the option of either using the software program, but if the computer's crashed, I want to still be able to physically override and turn on the light. Okay, so what we're going to do is we're going to add a diode, because we don't want to feed back the power and blow up our board. So we're going to rotate the diode around. You see there's a gray line on one side. We want that side to be going to our anode. And we'll connect it up like so. Now, we still need to connect here to the negative. So we put a jumper wire from there going down to here, and that's going to be black because that's our return path. Okay, so I hope you followed along with what we've done here. We've added in a switch. We've connected that switch to the positive terminal, so we have power coming in. When the switch is closed, power will come out. It cannot flow back into the Arduino to pin number 3 because of the diode. That's the gatekeeper. It stops the current from flowing in the other direction. So the only way it can go now is into the LED, out, and back to ground. So now if we run this, we should find that we can turn on the LED and we're no longer blowing up our Arduino. But at the same time, we can still turn it on and off using the other switch. So now we have one switch here which is physically connected to the LED. So even if the Arduino program broke, if we had a bug in our program, and we still needed to turn the light on in an emergency, we still can, as long as we have power, because we have this physical connection with the power going through the switch to the LED. As opposed to this one here, where there's no physical connection, we are just signaling the Arduino to send the power out to the LED. So I hope all that makes sense, and this is a little introduction to you as to what a diode is and how we might use it in a circuit. And also Tinkercad. So I'd encourage you to go to www.tinkercad.com and go and start playing around with building your own circuits and writing your own code. Follow along, like and subscribe to our channel so that you can be kept up to date, and follow along with Rhiannon and I on our journey into electronics. See you next time.